This is Duncan Fowler, and this is part of the lecture program on eco-engineering and sustainable engineering, and we're going to talk today about electrical vehicles, or EVs. And like a lot of the presentations within this lecture program, I'm just going to remind you that everything we say today, which is November 2023, will have an expiry date, and this is so true about this very topic, and it's changing weekly, daily, and there's also a tremendous amount of misinformation out there, so you really do need to do your research. So what we're going to do is we're going to go through this, and hopefully to be a starter for you guys to start your research, but do your due diligence, because there's so much misinformation out there and counter arguments for one type of power system over another. So we're going to look at the focus of this is on EV batteries, charging speeds and costs and comparisons and stuff, and looking at alternatives for fossil fuel. We're going to look at EVs, battery electric vehicles, or BEVs more accurately, and their significance in the sustainable transportation. There is evidence of increased popularity and adoption of EVs worldwide. This is true today, although I have read literally this afternoon an article discussing this, that's saying that EVs and BEVs hybrids are starting to plateau and stuff. So what are the advantages? Hopefully it'll be cheaper maintenance. I am not convinced that is now true anymore. Reduced emissions, that might be when the vehicle is running, but like with all of these presentations, we've got to look at the sort of where the batteries, the material for the batteries have come from, over alternatives and stuff. So it's the full life cycle of the vehicle that we need to be looking at. Reduced noise, yes, they are very quiet battery electric vehicles, and sometimes this is not a good thing. My own experience is within the village I live. We have a blind person who walks there as a guide dog, and the guide dog is not picking up on electric vehicles, so we need to be aware of that. So there's a safety implication of that. Disadvantages is price. Yes, they're very expensive. There's not enough charging stations, true to some extent, but you can charge at home, but then unless you've got a driveway, that becomes an issue. Recharging takes longer, true again, but this idea of anxiety of how many miles you can do, it is misleading. Most people travel well under the maximum expected mileage for an electric vehicle. I myself do 10-15 miles on a regular basis, but not very rarely do I go over 200 miles in one stint. And even with that, with a little bit of planning, you can stop off at service stations or similar and charge up 20-30 minutes. So energy hierarchy with the most favored options. So the most favored options are at the top. So energy saving, leaner, switch off, eliminate waste. That's one way of doing it. If we switch off things, if we're keener, energy efficiency, better appliances, lower energy losses. So lots of equipment within a house has sort of gradings now, sort of ABC gradings, as do buildings and stuff, so we can get better appliances, so our emissions are lower. Greener, so renewables and stuff, so sustainable energy productions. Cleaner, low emissions carbon generated, so it's still creating carbon, but it's cleaner. And meaner, which basic sources of last resort. So we're trying to get to the top one, energy savings. For electric vehicles, EV batteries store electric energy to power the vehicle's electric motors. Unlike traditional internal combustion engines, which use fossil fuels, EVs or battery EVs rely on electricity, making them an eco-friendly transportation option. This is questionable because you've got to look at where the materials come for the battery. So if it's a lithium battery, sodium ion batteries are starting to appear now, and they have a bigger capacity. They're quicker to charge. They seem to be lasting longer, but all of this is a very fluid subject area. So again, you must do your due diligence. You must do your research, because if you just took electric vehicles on their own and didn't look at the life cycle of the electric vehicle, you may consider things like the lithium batteries are very good in their car, but what happens, where does the material come from, and what happens to it at the end? They're now sort of talking about a lot of car batteries being used as storage systems for solar panels. So advantages of EVs: lithium batteries are known for their longevity, allowing them to withstand numerous charges and discharge cycles without significant loss of capacity. You must know the thing that if you keep charging your mobile phone and charging it to the full, it does tend to damage the battery. So you've got to take a little bit of ownership over this. So and lithium batteries additionally have a high charge and discharge efficiency, resulting in less energy wastage. Hydrogen fuel cells and hydrogen combustion, so JCB, have spent an enormous amount of money on hydrogen, and hydrogen vehicles that have use hydrogen for their fuel. Hydrogen vehicles include hydrogen fueled space rockets as well as ships and airplanes. Power is generated by converting the chemical energy of the hydrogen to mechanical energy, either by reacting hydrogen with oxygen in a fuel cell or power electric motors, or less commonly by burning hydrogen in an internal combustion engine. So hydrogen does seem like a good idea for cars. There's an infrastructure with petrol stations and stuff to convert them to more to deliver the hydrogen, but we've also got to consider where does hydrogen come from. Do a little bit of research in the different the graded in colours of hydrogen from I believe at the moment it's 90% of hydrogen. It's actually dirty. It's really not very good. You can get hydrogen now that is much cleaner and friendlier for an environment, but it's not in common use. So again, if you just took hydrogen cars and vehicles as it is, then you might think it's all it does is generate water, but it's where does that hydrogen come from you've got to be looking at. Hydrogen is not always green. Hydrogen is green if made from electrolysis of water, and so we have these different color gradings for hydrogen. Currently, 90% of hydrogen is made by stripping the carbon out of the natural gas and venting into the atmosphere as CO2. So we're creating CO2 before it gets to the vehicle. BHP says battery electric cheaper than hydrogen as it dumps diesel for haul trucks. So BHP have decided to go to hydrogen batteries. Biofuels comes from fatty oils and stuff that are produced by vegetables and animals. There are not nearly as many harmful pollutants that are being put into there as it is being burned. In fact, biodiesel products 40% less harmful particulate matter than a regular diesel fuel. This means that biodiesel burns much cleaner than regular diesel, which makes the air safe to breathe. According to the Department of Energy, certain variations of biodiesel have the ability to reduce engine carbon dioxide emissions by up to 70%. So that's another alternative. PHEV, plug-in hybrid electric vehicles. Uses a battery to power an electric motor and another fuel such as gasoline to power an internal combustion engine. So it's sort of an in-between type thing. BHEV batteries can be charged using a wall outlet or a charging equipment by the internal combustion engine through the brake when a car brakes. That energy that's generated by braking is used to charge up the battery. The vehicle typically runs on electric power until the battery is nearly depleted, and then the car automatically switches over, and it's a seamless switch over. But these, you're plugging in a hybrid. On an alternative type of hybrid is the mild hybrid electric vehicles, which it is similar to the plug-in, but basically it's not your plug-in. Unlike the hybrid electric vehicle, an MHEV does not run solely on electric power, although the ICE can be shut off during braking, coasting, and stopping. In addition, even when the internal combustion engine is switched off, the electric motor can power non-essential features. So it's sort of a midway between fully electric and a combustion engine, but it's not used. You don't need a charging station. But when you're using your internal combustion engine, you are paying for carrying that heavy battery around. So the fuel consumption, just as it stands, may not be as good as just a standard a combustion engine itself, because it's got the weight of the batteries, which are very, very heavy. Yeah, it's something else you need to consider when you're looking into this. The weight of the electric vehicles are very, very heavy. The wear and tear on the tyres is considerably more than a lighter internal combustion engine, and also the wear and tear on roads. You've got to think about that, because they are considerably heavier. So hybrid electric vehicles are the most common type of hybrid, and they have been around longest too. HEVs have two power drives, a fuel-based engine and an electric motor with a larger battery. When the car starts, it first rolls under electric power, then as soon as the vehicle achieves speed, the gas engine. So this is what we've just said, basically just repeating what we've just said. It's basically it regenerates the electricity through the braking. So battery vehicles, BEVs, are powered entirely by electric means, and has no internal combustion engine. So again, I'm just going over another way of thinking of it. Hopefully you're getting the idea of, you can see the picture on the side is basically a little plug-in. But you've got to start thinking about where you're going to plug it in, how much does it cost, the difference between charging at home compared to charging at maybe the supermarkets or motorway service station is considerable. You know, it could be difference between 7p compared to a pound for the same amount of electricity and stuff like that. And also time frames. If you go to a fast charger, maybe at a service station, it will do it considerably faster, maybe 20-30 minutes to charge an electric vehicle, where at home it could take you 2 or 3 hours, up to 8 hours. But when you're at home, you get the convenience of it, and you can also set up the system so you can say, well, look, I want my electric vehicle to be 90% charged by 8 o'clock in the morning, and through the night charge up. And because you might have an electric tariff that changes every half an hour, it then knows which tariffs to jump onto to charge the car up, so you're charging through the night on the cheapest tariffs, which is a really good idea. So charging speeds, so we've basically got three. So we've got the standard level 1, which we use as 120 volts. The level 2, which is the 208 or 240, sort of say. And then the level 3, which is a DC rather than the ACs, and can go up to 480. So charging 1 is the most basic and accessible charging options for an electric vehicle. They'll plug in the EV into a standard household plug. Charging is the slowest option, obviously, providing typically around 2 to 5 miles of range per hour. This level is ideal for overnight charging at home or in locations where level 2 and 3 just can't do it. Level 1 charging is the slowest, taking around 8 hours to 20 hours for a full charge, depending on where you are. Level 2 charging is more advanced and widely available option for EV owners. It requires a 240 volt AC electrical outlet, which is commonly found in residential settings and public charges. A lot of new houses now are having these put onto the side and stuff. It can take significant less time to charge, so we're offering about 10 to 30 miles of range per hour. Public charging stations with level 2 capacity are often located in parking lots, shopping centres, and on the roads and stuff. EV owners are often installed level 2 charging at home. It's normally costing between £600 to £1,000 to get one of these installed. Again, as time goes by, I expect that to go down. Many EV models come with an onboard level 2 charger, making it easier to utilize. And level 2 charging is faster, usually taking about 4 to 8 hours for a full charge. So if you're completely empty, you should be able to charge it up through the night and bouncing between different tariffs as well, taking advantage of cheaper tariffs throughout the evening. Level 3 is a DC faster charging. It's a rapid charging system, and it can take as little as 20 to 30 minutes to fully charge a vehicle, but these are not found around the house and stuff. They're not found in residential areas. They're more in motorway service stations and the like. So considerations when selecting charging levels, consider factors like your daily driving. So you need to do, when you're thinking about an electric vehicle, think about what do you normally do. So for me, I might drive 25 miles a day, Monday to Friday, and maybe once a week I might go and visit family, which would be approximately 60 to 120 miles away, depending which one I go to. I'm still within the range of my normal EV batteries single charge. So I don't really, I'm not worried about my vehicle running out. I do have one travel which is nearer to London, which is a 200 mile there and 200 mile back. So I would have to plan my journey, but even within that, within 200 miles, you should be stopping and taking a break anyway. So if you can fast charge, it is still a good thing. But you have to plan ahead and work out where these are. Home charging versus public charging. Home charging convenience, as it allows EV owners to charge their vehicles overnight while they are parking, provides the lowest charging costs, considerably lower than public charging costs. Although I think as more public charging comes available, I think that price will be lowered. But obviously with public charging, especially the sort of the level 3, it's the speed. So if you take a typical example, for example, we have a gentleman called Mr. Parker, and Mr. Parker is a true person who's very much into electric vehicles, and having had a discussion with him. This data is live from him, if that makes sense. So what he's saying is, if he has a vehicle that has a battery capacity of 40 kilowatt hours, but it varies greatly between different car models, so you need to look at your car. But Miss Parker's EV, like I said, he's got a 40 kilowatt hour charge, and he charges his overnight. Overnight electricity for him is 7.5 pence per kilowatt. So to fully charge his vehicle from zero would cost him £3. And this typically would give him a 150 mile range, and costing him 2p a mile. So home charging, he tells me, for him is roughly about 7.5p per kilowatt. At his local supermarket, it's 50, and on the motorway, and this is probably level 3, so it's probably faster, is £1. So the average UK motorist does about 7,000 miles a year. That's 20 miles a day. Yet manufacturers are pressed to produce vehicles that are capable of doing 300 to 400 mile range on a fully charged battery, whereas a typical car is made with two battery sizes, 200 and 300 miles. So Mr. Parker's idea of he admits that he's well within the 7,000 mile range for in a year for him. So it makes total sense that he has now got an electric vehicle. EVs will be cheaper as fossil fuel vehicles in Europe. So there's new government legislation and things, and although they are changing, they've already changed in the last month or so, when it's expected companies will be selling solely electric vehicles, or I think that's going to be electric vehicles and hybrids personally, and I think that date is slipping the longer we keep talking about it. But what isn't slipping is the fact that they've got to produce a certain number of electric vehicles in the next 1 or 2 years, or else the companies will get fined. So electric vehicle costs will go down. Understanding kilowatt hours, we will explore the concept of what is a kilowatt hour and how to calculate it and its connections to miles per gallon. This is flexible. You've got to do your research about this now. This is true today, but there might be some a little bit of differences. So what we're saying here, that the facts are the same, but the numbers may change. So a kilowatt hour stands for kilowatt, kW, which is measurement of how much power an appliance needs to run. So a kilowatt is 1,000 watts, kilo. AH or amp hours, sometimes abbreviated to AH or amp hours, is the amount of energy charge in a battery that enables 1 amp of current to flow for 1 hour. So a kilowatt hour is a measure of how much energy you're using per hour. As AH is a measure of electrical current amps, and kilowatt H is a unit of energy. So kilowatt hour stands for kilowatt hour, sorry, kW. A unit of energy used to measure electricity consumption. It is commonly used to calculate how much energy an electrical appliance or device consumes over time. For example, if you leave a 100 watt, not kilowatt, 100 watt light bulb on for 10 hours, it will create it will use 1 kilowatt of energy, 1 kilowatt hour of energy. The formula to calculate kilowatt hours is reasonably straightforward. So it's power in watts, time in hours divided by 1,000, because we're in watts and we want the answer in kilowatts. So kilowatt used by, let's calculate the kilowatt hours used by a 60 watt lamp top left on for 4 hours. So it's a 60 watts times 4 hours divided by 1,000, because we want it in kilowatt hours, not watts. So we get a 0.24. Now we're very much bought into the concept of miles per gallon. So this is a nice example of how to sort of convert kilowatt hours to miles per gallons. So miles per gallon is a measure of fuel efficiency used for vehicles, represent how many miles a car can travel with 1 gallon of fuel. So we're trying to find out what's the equivalent and therefore how much it costs. So we've got a reasonable idea of what the understanding of a kilowatt hour can help, and let's see if we can convert it. So to compare the efficiency of electricity and gasoline powered cars, we need to convert kilowatt hours to equivalent energy in gasoline. For this, we use the following conventional factor. So this is basically if an electric vehicle can travel 100 miles on 37.7 kilowatt hours of electricity, it will be rated with an miles per gallon equivalent of 100 miles per gallon E. So 1 gallon of gasoline is equivalent to 33.7 kilowatt hours. So to calculate energy equivalent in gasoline, we use the following formula. Energy equivalent in gasoline is equal to the energy consumption in kilowatt hours divided by 33.7. So let's say an electric car consumes 30 kilowatt hours of electricity to travel 100 miles. To find the equivalent miles per gallon, energy equivalent is gasoline, so we've got 30 kilowatt hours. That's how much we're going to use. We're going to divide it by the 33.7 kilowatt hours per gallon. That gives us gallons of 0.87. So miles per gallon, so miles travelled divided by equivalent gallons equals miles travelled was 100, and equivalent gallons is 0.87. So that gives us approximately 112.4 miles per gallon equivalent, with the electric vehicle. Conclusion: by being energy conscious, we can make informed decisions to reduce energy consumption and contribute to a sustainable future. So the maths we've discussed, they might change slightly, more as we get to know and understand the equivalents and stuff. But it is a starter. The idea of how we charge our cars is important. The different ways of charging, and the different types of cars that are options, from the hybrids, the electrics, to the hydrogen, and also where the fuel comes from and where the battle. We've said that hydrogen fuel is clean when we've got it, but to produce it at the moment is very, very dirty. So it's sort of this idea of brown hydrogen. Have a look at the different colours. It's a sort of a standard for how it's produced. If we can produce hydrogen cleaner, then that becomes an interesting factor in all of this. But then we've got to start looking at the lithium batteries, whether the lithium batteries, the production of a lithium batteries can be very dirty. What happens to the lithium batteries when they've finished? It's a life cycle of all of this, where the different types of batteries, sodium ion batteries, and similar. So it's all part of a very big discussion that is moving. So do your research. Don't just take one person's opinion. You need to get multiple factors involved in here and consider the life cycle of the vehicle you've decided to go for, you're recommending and stuff. Okay, like I say, everything's got an expiry date here today, so please do your research. Hopefully what we've discussed is at least a starter for you, and gets you interested into the topic and gets you interested into the idea of doing your own research. Thank you very much.